Hello, in this particular video, I will show you how to improve predictive accuracy by modeling the forecasting errors using an autocorrelation model. So this is your Coke sales dataset, and if we plot the data, it typically looks like this. Um, so you see that the sales are going up. You do see some seasonality. And if you have developed a model-based forecaster, the best model is exponential model with dummies to capture seasonality. So what we're going to do is the story of this particular lecture video starts after you found your best model. And obviously the best model is the exponential model with dummies to capture seasonality. And the thing is whether the assumptions you have made by assuming an exponential trend and dummies to capture seasonality, in this case the dummies will be the quarterly dummies, is a correct assumption or not. So to do that, to test for that, what I'm going to do is I'm going to use this video to forecast, let's say, next 4 observations, and we're going to update and obviously and improve the predictability of those 4 observations by first checking the SCF plot or autocorrelation function plot of the residuals of the model, and based on the number of lag terms that are significant, we're going to show you how you can improve the predictability of that next 4 values. So in order to model an exponential trend along with dummies, we need to kind of calculate create a few variables. First thing is we need to create our dependent variable in an exponential trend model is a log of sales. So I'm going to use the natural log function, which is ln, and then I'm going to tell them that calculate the natural log of the sales column. After that, we have this is a quarterly sales data. So we need to create quarterly dummies. So let's say I'm going to create D1, D2, D3, D4 are the different things to do that. So I'm going to create D1, D2, D2, D3, and D4. The four for the 4 dummies we can look into it. So to create the dummies, once again, we are creating these dummies to capture seasonality. So D1 represents the dummy for quarter 1, and the whole idea here is we are creating these indicator variables so that we can indicate which row belongs to which quarter. So as you can see, I'm creating a zeros 0 1 0 for a quarter 3 data set, and then quarter 4 will be 0 0 0 1. And what I normally do is I obviously there are many ways you can do this. I just copy this and then I just paste around for the other years. I'm sure there are many ways you can do this in Excel, and also if not, you can actually also write a code for a bigger data set in R or in SAS, and you can create the dummies based on the values. So what I'm going to do is I'm going to just delete the last 2 rows because those are beyond our data set. So that's what we have. So the next thing is to kind of, since we know that the best model is the exponential trend model with dummy variables, we're going to create this new spreadsheet where we are going to forecast the next 4 values. To do that, I'm going to create this new spreadsheet and I'm going to name it as let's say new values and new values. That's the name. Now you can give whatever name you want. It doesn't really matter. And then I'm going to copy the names of this data set, names of the variables in this data set. And then I'm going to just go down at the end. My goal is to forecast next 4 values. So I'm going to just create the next 4 values with whatever we can. So for example, the next value is a quarter 396. Then it's quarter 496, then quarter 197, and then quarter 297. Similarly, we know what else we know is we need to also create a time index, because if you think about an exponential trend model, we do need to have the time index, which is t, time index. So t will be nothing but 1, 2 is just telling indexing each observation of the data set. And then if moving forward, obviously this is the first new observation will be time index of 43, then 44, 45, and 46. We also can provide in the dummy variables. So this is a quarter 3 data set, so it'll be 0, 0, 1, 0, and then the next one will be a 0, 0, 0, 1. The third one will be 1, 0, 1, 0, 0, 0, and the fourth one is 0, 1, 0, 0. After doing that, what I normally do is I just copy and cut from this particular spreadsheet, and then I just go and paste it in the new spreadsheet we created. Okay, and then the goal will be to, and this is a time index e, and then the next step will be to kind of delete the dependent variable from this particular spreadsheet. And the whole idea here is we are going to forecast new 4 values, and we have to tell the program or Excel miner what new inputs they need to consider to forecast the future values using, in our case, an exponential trend with dummies to capture seasonality. So what we'll do is we'll go to Excel miner, and then after that we're going to go and do predict multiple linear regression. Within that, we want to, since we already know the best model, we are not partitioning anything. We are just, this is a story where we have found the best model and we are going to forecast new 4 values using an exponential trend with dummies to capture seasonality. So for an exponential trend model, the dependent variable or the output variable is the log of sales, and the independent variables will be t, and then any of the three dummy variables. So what I will do is I will select d2, d3, d4. Now the results will not vary in terms of the forecasting values. However, the way you will represent and illustrate and examine each of the coefficients for the dummies will change. So keep that in mind when we are doing this. After that, I'm going to click next, and then we click standardized residuals. Then maybe I want to do the detailed report of the training period, because if you do not click on this particular button, you will not get the residuals, which you need to test with SCF plot to see whether the values we got are really the assumptions we have made in terms of the exponential trend and the quarterly seasonality are correct or not. The next step will be to kind of click on this in worksheet. So what we are doing is by clicking this particular button is we are telling the program what variables they need, what spreadsheet they need to look for where they have information to predict the future values. So the first thing we should do is we should select the worksheet and highlight the new worksheet you have created. As you can see, new worksheet is the new values with the information we are aware of. And then the next step will be to kind of click match by name, this particular button. When you do that, what you're telling the program is the variables you see in this particular spreadsheet have the same meaning as the variables which are in the original data set, okay, which was a part of the particular model. After that, we click OK, and then we click finish. So what you will see here is you will see a spreadsheet saying MLR new score, and these are the new values which have been predicted, the new 4 values. Now, as you can see, these values are in the log form. Okay, since the dependent variable was a log of sales, these are in the log form. So, in order to come up kind of a convert it back to its original value, we need to kind of convert it by using exponential. So, what I will do is just to show this, I'm going to say predicted values, and then I'm going to say equals exp. Now this is the function for doing exponential of the log values. So we need to just select the cell where you have the forecasted values, and I'm going to just drag it down, and there you go. So these are the new forecasted values for the future. So now the next question here is, well, the assumptions you have made in terms of an exponential trend and quarterly dummies, because we have 4 dummy variables to capture each of the quarter information. Are these assumptions really correct? So to test for that, we need to do is we need to think about what's in the residuals. So what we're going to do is our goal will be to run an ACF plot of this residual column and see whether any of the lag terms are significant or not, lag values. So to do that, we need to go to ARIMA, and then within ARIMA, there's something called autocorrelations. We're going to select autocorrelation, and typically what I do is and you cannot really see all these variable, there's no name, and that the reason is, and there are so many different variables in this table, it typically becomes difficult. So what I always recommend is, manually select the data range. So here I'm selecting the residuals data range, and then which is from D16 to D57, and I click OK. Now when I do that, you will see only one variable, var1. I select that as the variable I want to compute ACF for, and then I will change the lag to lag 12. Now what this tells you is, as I'm telling the program, is to provide me the correlations until lag 12 values. That's what it is. And then I make sure that this plot ACF chart button is selected, and I click OK. So when I run this, what I see now here is we have a situation where looks like we have a few lag terms that are significant. So let's look at this. So this is an ACF plot. ACF stands for autocorrelation function plot. What it does is it tells you the correlation values between the lag terms. So if you look at the x-axis, these are the lag terms, lag 0, 1, 2, so on and so forth. Now, lag 0 means you are computing the correlation with the same observation. That's what lag 0 is. And that's why it is 1, because you are 100% correlated with yourself. So it's 1. Lag 1, which is the correlation between y of t and y of t minus 1, and that is a significant correlation. Now, to look for significance or not, what we need to do is we need to see whether any of these bars touching or crossing the upper and lower bound. These are the 95% confidence levels, and what you see here is looks like a lag 1, lag 2 are touching or crossing these lines. And also if you really expand and focus on this particular plot, you will see that even lag 12 is also touching. So Normally, what happens is when you get this particular result, the whole idea now is that looks like the assumption we have made in terms of exponential trend and quarterly seasonality may not be appropriate or maybe incomplete. We don't know what it is about. So to do that, so what it means is these forecasted values we got by running this model obviously still can be improved on. Okay, so to do that, if you look at the lecture slides, what we talked about is one of the approach of doing this is by running a second layer model or a two-layer model. To do that, what happens is the residuals becomes the a dependent variable for a new model, and the independent variables will be an AR model or autoregressive model. So we have autocorrelation and component. The lag terms depends upon your ACF output. And typically the lag terms you're going to select as independent variables is equal to the number of lags that are significantly correlated. So in this case, now zero, we obviously not worry about the zero lag, but for lag one and lag two, we have a significant correlation with the observation. So in this case, we have to kind of consider those as our two variables in our model. Now, one may argue and say, hey, what about lag 12? Looks like lag 12 is also touching the lower confidence level. And the reason here is, if you want to need to include lag 12, from a technical standpoint, we have to include all the lag terms between 2 and 12. We cannot just pick and choose lag 12 in our model. So what we do is we typically start with the lag which are close to 1, 2, and 3, if they're significant or not in terms of correlations. If they are, then we just put those in the model. And normally, if you do that, chances are your farther lags effects are also taken care of. So given that we have a lag 1, lag 2 are significantly correlated with with the observations. So what we're going to do is we're going to run an AR2 model on the residuals, where the residuals will be your typically is your dependent variable. So what I would recommend is this. I would recommend that you create a new spreadsheet. It's always good to create these new spreadsheets so you know what you're doing and you have a track record of what things going on. So what I will do this, I will just say this as the residual model, and I'm going to have two columns. One will be say T, the time index, and the other one will be residuals. And so the reason I'm creating this spreadsheet is I want to run this new model, which is AR2 model, because we want to adjust our forecasted values because we found out that our ACF is not doing good. It looks like ACF is showing that our lag 1 and lag 2 values are significant. Correlations are significant. So I just copy pasted those things, and then I just did 1, 2, and I created the time index. Now, given that we have done this exercise, this particular output is from the full data set, because we did this while we were forecasting the new values. These obviously this time index is really from the beginning of our data. So the next thing will be, in order to forecast using an ARIMA as an AR model or autoregressive model, there are two ways you can do it. You can obviously create two lag terms, lag 1, lag 2 of the residuals, and write in the regression format. Or alternatively, which I prefer, is to run an ARIMA model. Now, ARIMA stands for Autoregressive Integrated Moving Average. And what it does is, it's under ARIMA, and you click on ARIMA model. You can actually tell the program to run a moving average, You can tell the program to do an auto regression, or you can also do a differencing, and you can actually do a very hybrid model of doing multiple things with this particular platform. For us, we are only focusing on AR2. So for us is the T is the time, and the residuals is our the variable we are doing. And then what we're going to do is we're going to say we are going to run our 200 model. Now 200 model means you 2 stands for the first 2 stands for the autoregressive part. Now, what we have found out actually is there's the ACF plot showing that lag 1, lag 2 are significant. And therefore, we select 2 as our autoregressive model. So AR2 is what we are fitting. And since moving average and differencings are 0, a 200 ARIMA model is nothing but AR2 model. Okay, so that's what it is. Moving forward, I can just click on fitted residuals, and we can actually say, okay, produce forecast. Okay, and we can tell, okay, produce 4 forecasts. Okay, so there are many ways we can do this. This may be a simpler way is to kind of produce next 4 forecast, and then we can add that information directly to our new score model. Now remember, our goal here is to do a predictive accuracy. We are trying to improve our predictive accuracy by checking whether the assumptions we have made in the model are correct or not. And the second, if they are not complete, which is captured by the ACF plot of the residuals of the model, we then have to model the error and kind of improve our forecasted values. So in this case, what we did was we just click on produce forecast, and since our goal is to forecast next 4 observations for this data set, I'm going to click OK now, and then I will click OK here, and we get some output. Now, if you look at the output here, you're going to see, the forecasted values are here. You can actually also see the coefficients of the model. Now, you can actually use these coefficients directly as an equation, as a second layer equation, and put that into the model. Or you can actually take these outputs, the forecasted value outputs from here, and add them to our or the new 4 values we got. Okay, but before we do that, we want to kind of also check and see whether the model we got, the residuals we got after running this AR2 on the residuals of the original model is free from all the other issues. Now if it is not free, then we have to kind of run another layer if we can and do that. Now, it is advisable not to run this more than 2 layers. So in this case, the first layer will be the original model, which is an exponential trend with dummies to capture seasonality. And in this case, the second layer will be the layer where the residuals of the first model is the dependent variable, and to run an ARIMA 200 or AR2 model to kind of figure out can we capture anything that's left in the error. So to do that, what we do is let's try an ACF plot of these residuals. I'll click on residuals, then I'll select manually select the data range. For this, we go down, we select this, and then we say okay, lag 12, and the variable is the what we are doing ACF plot on, and we click OK. And what we see now here is it looks like after running this second layer model, our none of the variables in lag terms are significant. And also, as you can see, the lag 12 is not significant anymore. And it looks like, after when we did the AR2, although we just only used the first 2 lag terms in our model, it also took care of the correlations of the lag 12 correlations, which is observation at time t and observation at time t minus 12. That was the significant correlation we saw last time. So given that we found that this is working well, the next step will be to really look at the output, the residual output, which is the ARIMA output, and These are the forecasted new values. I'm going to copy these, and the whole goal is our goal is to really look at the new values we got first time we ran, and improve these values, right? So we improve these values. So what we can do is, since we copied that, I'm going to paste it here. These are the output from the error. Okay, I can just write second layer output, so people are aware what we are doing here. And then the what we can do is, we can do two ways we can do it. Typically what I would recommend is, we can actually add these, and then do an exponential. So what I will do here is, I'm going to do a shortcut, in the sense I'm going to say adjusted values, and I'm going to directly do an exponential, where I'm going to add the predicted value, and we're going to also add the second layer model output, and that's it. And then these are the adjusted values. So if I want to tell you that, what is the forecasted values, based on for new forecasted values adjusted for any kind of error, a forecasting error, this is what we did. Now, if you look at the values itself, it's not a huge jump. Like at the beginning, when you ran the first model, which is the exponential trend model with dummy seasonalities, it had a 5,105, and adjusted values are 5,169. But it is pretty also a pretty important element. So typically, what I do is, I typically copy these adjusted values, put it with the real, put it in this particular model. Let's say in this case, I'm going to, let's say the original data. But original data doesn't have any residuals, right? So the idea would be to kind of look into, and maybe I can, let me see, I can then directly copy this, copy these maybe, okay, and we can adjust. So for example, what I'm saying is, we can just say adjusted value, which is a log of adjusted values. And because I just wanted to show you, how the output looks like. Okay, and since we do not have the forecasted value in normal form, because I want to just copy paste this, and beyond this, and just plot the new values. So to do that, I'm going to just do just addition of the predicted values of first and second layer, and that's what we have. Okay, these are my values. I'm going to then copy these. Now make sure when you're copy pasting these, there are formulas here, so make sure you just paste it just as a value. To do that, you have to just go home and go to paste, and then you say paste values. Okay, and that will paste only the values and not the formula. If you don't do that, you're going to see an error. So after that, I'm just going to select those two columns, and do the plot, and that's how it looks like. Now once again, if you don't do the adjustment and run it without it, you might see a bit different values, but not a whole lot difference, because if you look at the log, in log format, they are pretty small changes, unless you really convert it back to normal values. But in any case, keep that in mind, that the correct way of forecasting new values will be to run the first model, or the best model you have. Now this can also be done at the also for data driven approaches. But let's say your best model in our case here was was obviously your exponential trend model with dummies for seasonality. And we found out after, by running the SCF, that there is some problem with the SCF. Looks like our lag 1, lag 2 were significant. So what we did was, we just took those residuals, create a new spreadsheet, and then run a ADIMA 200. 200 stem means AR2 model, because moving average and difference is 0. And now there are two ways then you can actually improve your forecasted values. You can tell the program to forecast new 4 values, and you can add that directly to your data set. Okay, or which is here, or you can actually use those coefficients. For in this case, the coefficients were Let me see. Let me go back for a minute. The coefficient in the ARIMA output are, you know, your 2.03 into 10 to the power minus 16, which is the constant of the second layer model. Then the constant, the multiplier for the AR1 component is 0.75, and for AR2 is minus 0.076. And you can actually put that in the equation and calculate the future values. Alternatively, since we have a way of forecasting new values directly from Excel Miner, we can just select that particular button, and then we can use these values, copy these to our data set, new score data, and then we just to get the adjusted values, we just add these values, the predicted value and the second layer output, and then we just do an exponential of that. Okay, and then finally we just copy paste it in our data set, and then we just plotted this data just to show how the new four values we looked at. I hope you have understood exactly how to do a second layer model. But once again, now, although I have demonstrated this for a model based forecaster, where you have an exponential trend model with dummies to capture the original trend and seasonality. However, this approach can also be used for a data-driven approach, where you first run a data-driven model, and then you got your best model, let's say a Holz Winters, and then you do an SCF on the residuals or the errors of that particular output. And if the residuals, if the SCF plot shows that there are significant lag correlations, then you run an ARIMA AR model to capture that. I hope you enjoyed this. Thank you for listening.